I'm a JavaScript developer. Is it important to learn TypeScript? I'm a front-end developer. Will TypeScript still help? Can I learn or should I learn TypeScript before learning Node, React, etc.? The answer to all these questions is a hard yes. So the next question is, how long does it take to get started with TypeScript? And my answer to that is it takes 60 minutes. That's the purpose of this video. I'm going to get you started with TypeScript in next 60 minutes. So what are we waiting for? Let's just get started. So here on your screen, you can see the formal definition of TypeScript. TypeScript is a strongly typed programming language that builds on JavaScript, giving you better tooling at scale. So if this definition didn't explain much about TypeScript, this graphical representation will undoubtedly do a better job. Think of TypeScript as a superset of JavaScript, which includes some additional syntax as compared to JavaScript. So getting started with TypeScript is very easy because you're using JavaScript and adding to the syntax as you progress at your own pace. The benefit of using TypeScript, however, lies in the additional features that it offers you as compared to JavaScript as a programming language. So you get these features that are mentioned on the screen, such as script typing, extensive object-oriented programming capabilities, in-editor checking, auto-completion, and so on, which are not a part of JavaScript. I can assure you one thing, once you start programming in TypeScript, you would never go back to JavaScript. Now the question is, how many developers actually use TypeScript? Let's look at some statistics. So if you look at the Stack Overflow developer survey, you'll see that TypeScript is the most wanted programming language that developers want to learn only after Rust and Python. TypeScript is also the fourth most loved programming language amongst the developers. Also, if we look at the State of JavaScript Survey 2022, strict typing is the most wanted feature that JavaScript developers would like to use today. And that's the selling point of TypeScript, as that offers strict typing out of the box. And mind you, this is not present in JavaScript as of now. If we look at this State of JavaScript 2020, we can see that 78% of JavaScript developers use TypeScript for development. Also, if I open up another statistics over here, you will see that 93% of JavaScript developers who have used TypeScript once say that they would use TypeScript again. Now, obviously, this survey was conducted in 2022 and we are sitting in 2023 as of now. And the percentage of community that uses TypeScript has definitely increased. So what are the prerequisites of taking this course? What all you should know before you can start learning TypeScript? Here on your screen, you can see the prerequisites that are needed in order to start with TypeScript. Well, you should know JavaScript in order to learn TypeScript. That's first things first. There's no TypeScript without JavaScript. I don't expect you to be an expert in JavaScript, but you need to know the basics and be aware of the syntax, else you would not be able to understand as to why we are using TypeScript in the first place. So in order to follow along with this course, the first thing that you will need to have on your machine is Node.js. You can see Node.js website on your screen, and this is how you can download Node.js. This will also install NPM on your machine. This is not a Node.js or NPM course, so I'm assuming you already have this installed. And if you haven't, just go to this nodejs.org website and download the relevant version of Node.js for your operating system. I'm on Mac OS, so it's showing me the Mac specific version, but if you're on Windows, it'll show you the Windows version of Node.js. So simply click on this, download the executable, and install Node.js on your machine. When you install Node.js using this same executable, it will also install NPM on your machine. Now, once you have done this, we can go back to Visual Studio Code. And I have this empty project on VS Code. This project contains nothing, just a git ignore file and normal license and README files generated by GitHub. Now, once you have installed Node.js on your machine, you can simply check that by opening the terminal. So within terminal, you can type node ---- version command in order to check which version of Node is installed on your machine. My machine has 16.14 installed. I can also check the version of NPM by typing NPM version, and this will give me the version of NPM that is installed on my machine, and it is 8.3.1. Now, since we have npm and node installed on our machine, we can create an empty node project. In order to do so, I'll clear my terminal and run this npm command, that is npm init. This basically instantiates a new npm project inside this particular directory. And then we can use a y flag, which basically sets all the questions that npm asks you while creating a new npm project as defaults. So let's go ahead and create a new npm project. You'll see that the npm project is created and we have this package.json file, and we have all the default values within this package.json file. This should do the trick. And the next thing that we are going to do is we are going to install TypeScript. So we have this TypeScript website, and on this website, you can see the install script. This will install TypeScript specifically in your project. Some people like to work with a global installation of TypeScript as well. But for the sake of keeping it simple, we'll use this npm script and install it within our project. So back to VS Code, and here we can open the terminal. Let's clear the terminal and use the npm install script for TypeScript. Now, since TypeScript is installed on our machine, we are going to use Parcel in order to compile all TypeScript files to JavaScript. So let's see how we can integrate Parcel inside this project to quickly compile all TypeScript files to JavaScript. Let's go to the Parcel website. Here you can see we have this npm install script for Parcel. So let's just copy the script, go back to VS Code, and let's install Parcel here. I'll be back once Parcel is installed. Now Parcel is successfully installed. We can go ahead with the setup. So let's close our terminal, and within the root of our project, let's create a new file. Let's call this file as index.html. Now within this index.html, I'm going to write some HTML boilerplate code. Let's change this title, TypeScript Crash Course. Looks good. And then again, within my project, I'm going to create another directory, and let's call this directory as src. So within this src directory, we'll have all our TypeScript files. So let's go ahead and create a new TypeScript file as well, and let's call this index.ts. We have our first TypeScript file within our src directory. And since we are going to use Parcel, let's go back to index.html and let's include this TypeScript file within our index.html. What Parcel does is that it will look at this index.typescript file and it will compile it to JavaScript for you automatically. So let's link our TypeScript file here using the script tag. And within the script tag, we can mention the path of our index file. Once we have linked the index.ts file, we can add another attribute to this, that is the type attribute. And since we will be using modules, let's use type as a module. And what Parcel is going to do now is find this particular file, compile this file into JavaScript and serve it in the browser for us to enable us to develop easily. Now, in order to tell Parcel what file it needs to look at, we need to create a script in our package.json file. And that's what we're going to do next. So let's open the package.json file, and over here within the scripts, let's create another script. Let's duplicate this, and over here, let's create another script. Let's call this as a start script. Now inside this start script, I'm going to use two Parcel commands. The first command is going to be the watch command, and the responsibility of the watch command is to watch the TypeScript files that are inside or linked to our index.html file. And once any change is made to those index.typescript files, TypeScript would compile. And the second command that I'm going to use is for the compilation process. So the Parcel would compile once any change is made using the watch command. So inside the start script, I'm going to use two commands. The first command is going to be npx parcel watch. This command is responsible for watching all the changes that happen inside TypeScript files that are linked to index.html file. Using this command, Parcel will keep watching index.html and see for any changes. And now as soon as a change is made, we want to fire another command, and we're going to use ampersand for that. And then within this bracket, I'm going to use the Parcel command in order to compile as soon as any change is made to index.html files or TypeScript files that are linked to the index.html. This should be it for the start script. And apart from this, I want to get rid of this main property because it sometimes conflicts during the compilation of TypeScript files. So let's get rid of main. And there we go. That's our start script. We can test if everything is working perfectly or not. And let's go to index.typescript file. And within our index.typescript file, we will use a console log statement. And within this console log, let's say hello world. And now we can open our terminal and use npm start script. And let's see if the compilation goes well. A TypeScript has compiled and a local development server is running on this particular host. I will open this in Chrome and align the Chrome DevTools along with my Visual Studio Code here. And what you can see on the right side of your screen here are Chrome DevTools, and you can see Hello World is printed on Chrome DevTools, and that's what we expected. So we now know that our index.typescript file is compiling and we can start working on some TypeScript. Now make sure your npm start process is always running because this will keep compiling TypeScript and keep printing the output in the console. So having said that, let me give you the first taste of TypeScript. Let's say we have this simple JavaScript function. This is a sum function that takes in two parameters, that is a and b. I'll use the arrow function syntax, and from within this sum function, what I'm going to do is return the sum of a and b. So let's do return a plus b. A very trivial function indeed, and this is pure JavaScript and I haven't used any TypeScript here. Now let's try to run this sum function and get some output out of it. So I will use a console log statement, the sum function, and let's add 5 and 10. Now you will see that 15 is printed to the console, and that's what you would really expect out of this function. But there's a gotcha here. Now let's try to pass incorrect values to this. And what I mean by incorrect is let's pass a string instead of a number. Now you will see JavaScript doesn't throw an error but gives you an output, that is John 10. Now this is not what you were expecting from a sum function because you were expecting to add two numbers, but JavaScript went ahead and added a string and a number as well. And this is the cause of many errors in JavaScript. JavaScript doesn't have strict typing, and that's why this is problematic. Let me show you what I mean by strict typing. Now let's convert this function to TypeScript, and it is very simple. Let's say A is a type of a number and B is also a type of a number. Now what I'm telling TypeScript over here that whenever someone tries to invoke this function, we are expecting two arguments, that is A and B, and these have to be of the type of number and cannot be of the type string. Now you will see that TypeScript over here during invoking this function throws an error and does not allow the developer to invoke this function using one string and one number. And it says that argument of type string is not assignable to a parameter of type number. This is your first taste of strict typing where you strictly define a function and what parameters and what types of parameters can it accept. So here we know A and B can only be of the type number, and that's when this particular sum function is valid. And now since I'm using TypeScript and when I try to invoke this function using a string and a number, TypeScript throws an error. Now just like this number over here, there are many built-in types and you can also create custom types in TypeScript. So let's start with certain built-in types in TypeScript. Now let's look at some built-in types in TypeScript, and the first type is the any type. Now any type is a default type in JavaScript, which means that any type of value can be assigned to any variable. Let's say we have a first name variable here, and now you can assign any type of value to this. So first name can be Mark. In TypeScript, we have already seen that if we want to assign any type of strict type to a variable, all we need to do is use a colon and mention a type of value that we are expecting here. So here we can say that we expect any type of value. Now, since first name is of any type, what I can do is I can assign any type of value to first name. So I can go ahead and assign it a number and TypeScript will not complain. Any type is the most liberal type of types in TypeScript. Now in JavaScript, all types are any types, and the whole purpose of using TypeScript is to define specific types. So you want to avoid any type at any cost. Now the next type we want to look at is unknown type. Now unknown type is a little better than any type, and let's see how it is better than any type. And in order to demonstrate unknown type, let me create a JavaScript function. Let me call this function as multiply by 2. And this function would take in a single number. and multiply that number by 2 and return the value. So we can take the number, multiply the number by 2 and return its value. Now this is a simple JavaScript function, but we have all JavaScript problems related to this particular function because the number type is any type by default. And even if we pass a string, JavaScript is going to try it to multiply by 2 and return some kind of a value out of this particular function. Now we want this number to only be of the number type, which we will learn in the future. But for this example, instead of any type, I'm going to use an unknown type. Now you will see that the moment I say that number is of unknown type, a TypeScript understands that you as a developer also do not know what type of value the user will pass to this particular function because it is unknown. So here TypeScript is throwing an error and is telling you that number type is unknown, and it is telling you that you are trying to multiply an unknown value by 2, and you as a developer are also not sure whether this will be a number or not. So it is forcing you to check whether you are actually multiplying a number by 2 or not. So to get rid of this error, we can use an if condition and we can check whether this number that we are getting as an argument to this particular function is actually a number or not. And we can use the type of function in order to do so. So we can check the type of number and we can test whether the output of this function is actually a number or not. So if type of number is a number, then we can go ahead and multiply that number by 2. Now here I have checked whether my number is actually a number or not, and TypeScript is now happy. You will see that the error has gone away, and that's because TypeScript now knows that you have checked that number is actually a type of number, and now it knows that you can multiply this number by 2. Now this is better than any type because had it been any type, TypeScript would have allowed this kind of an operation where you could have even multiplied a string by 2. But here now, since it's an unknown type, TypeScript is forcing you to test whether the number is actually a number and then only multiply it by 2. Let's look at another type that is baked directly into TypeScript, that is Boolean type. Boolean, as the name suggests, is very simple. Either it's true or false. So let's declare a variable, call it Boolean type, and this Boolean type is going to be of the type Boolean. So this is how we define a Boolean type, where we specify the keyword Boolean. Now this variable can only hold true or false values. I can set the value as true. So here you will see TypeScript will not complain because it knows that this is Boolean type. So a Boolean type can have literal true and false values. And apart from that, it can also have expressions that evaluate to true or false. Now to this Boolean type, I can also assign an expression which either evaluates to true or false. And if that expression evaluates to true or false, TypeScript will not throw an error. So we can have something like this, type of ABC, and let's check if this evaluates to string or not. Now this expression would always evaluate to true, hence TypeScript understands that Boolean is of value true. And here TypeScript will not throw an error because this expression is a Boolean expression. Similarly, we can have other Boolean expressions as well. So for example, 1 is greater than 0 is again a Boolean, or 1 is less than 0 is again a Boolean, because this evaluates to true or false, and that can be stored in a Boolean type. Now, if I try to save any value which is not Boolean to this Boolean type, TypeScript will throw an error. So if I try to save this object, it says type object is not assignable to type Boolean. Similarly for string types as well. So anything that is not a Boolean, for example, a string over here, will throw an error. TypeScript will say string is not assignable to Boolean because Boolean type is of the type Boolean. So only Boolean values can be saved to this. On a side note, null and undefined are not treated as Boolean values by TypeScript. We can check that. So if I try to assign null type to this, TypeScript will throw an error. Null and undefined are two different types in TypeScript. They are not Boolean values. However, by a lot of JavaScript developers during JavaScript development, these are used as Boolean values, but TypeScript does not consider them to be valid Boolean values. Now let's look at another primitive type in TypeScript, that is the number type. So again, very simple. This is how you assign a number type. So you use the number literal string in order to assign the number type. And now this variable number will only hold a number. So a 10 can be a number. Any float or a negative integer value is also a number. So 28.7 is a number. and it's a negative float value. So you can see a negative number is also a number. Now, any expression that evaluates to a number is also a valid number. So over here, if I use infinity and multiply that by 2 is also a number because this expression evaluates to a number. Now, another example of this can be when you use parse int to convert strings to numbers. So over here, I'm converting a string to a number. This also can be considered as a valid value because eventually this expression in the end would return a number. And what goes without saying is that you cannot assign any non-number value to this. So the moment I try to assign a string to a number, TypeScript will complain saying that strings cannot be assigned to numbers. The next primitive types that we're going to talk about are the string types. TypeScript has its own string types. So just like the number type, you can declare a variable and assign it a string type. Now this variable first name will always hold string values. Now again, any expression evaluating to string can also be a string value. So first name can also be said as a concatenation of two strings. So I can say first name and then I can use the plus symbol to concatenate the last name along with this, and this will work. Because this particular expression evaluates to a string, TypeScript will not complain as long as you're saving a string in the first name variable. Just like with other strict types, first name can only hold a string. So if I try to save an object to it, TypeScript will complain. So any other value apart from a string cannot be saved in this first name variable. Next, let's look at how we can deal with arrays in TypeScript. So here's the basic syntax of creating an array in TypeScript. So let's say we have this variable a and we want this to be an array of numbers. So we can use the number keyword and we can say that this a will be an array of numbers. Now, since you have declared this array of numbers, you can save an array of numbers to this particular variable and TypeScript will not complain. Now here I've created the simple array of numbers and saved it to a. But the moment I try to save an array of anything else which is not a number, so let's say an array of strings, TypeScript will complain. Now this is the basic syntax of declaring arrays or strictly typing arrays in TypeScript. But there are two other alternative syntax of declaring array types. And this is how that syntax works. So I declare a new array and I call it B. And I use the array keyword and say that this particular array is going to be of the type string. Now I can save any string array to this particular array and TypeScript will not complain. Now if you need to have arrays that contain strings as well as numbers, you can use union types for the same. Now this is how you can declare a variable C, which would be an array of numbers and strings. So within the parentheses, you can say that this is either going to be of the type string or on number. And then you can use the array literal syntax in order to define that variable C is going to be an array which can contain numbers as well as strings. So now I can create an array here, and this array can contain numbers as well as strings. Now moving on, we can talk about another types in TypeScript, that is tuples. Now tuples are by default not supported by JavaScript, so they only exist in TypeScript. Tuples are nothing but arrays with a fixed length and type. Let me explain that with an example. We have this person variable, and this variable is of the type of an array. Now this array is going to be of a fixed length and of a fixed type. So we say that this array will hold three values, that is a string. The second value is also going to be a string, and the last value is going to be a number. Now this person array is a tuple because it has fixed length, that is it'll always have three values and each value is defined. So the first value is going to be a string, the second value will be a string as well, and the final value is going to be a number. So the person can be of this shape. I can say the first value is the first name, which is John. The second value can be the last name, that is Doe. And then third value can be the age of the person. Now this complies with this person tuple, and that's the reason TypeScript doesn't throw an error. So tuples are nothing but arrays with fixed length and fixed type. Now the moment I try to add another value to this person array, TypeScript is going to complain. Now, TypeScript complains because this does not comply with the tuple that we defined over here. Since the tuple had only 3 values and we are adding 4, TypeScript is going to throw an error. So tuples are pretty useful when you want to use arrays that have strict or fixed length and all the values in that particular array are strictly typed. Next, let's talk about objects in TypeScript. Let's assume we have this simple post object in JavaScript and slowly we are going to convert this into a strictly typed object in TypeScript. So let's say each post in our blog has an author. So we have the author property. Let's say the author is Stella. Then we have the content property. Hello world. And let's say our post also has a title. My first article. So we have this post object, but it's not yet strictly typed. In order to strictly type this post object, what we can do is similar to the pattern that we have been following previously, we can use a colon and we can say that post is going to be a type of an object. Now at this point, this is any object. Now at this point of time, post can have any number of properties and TypeScript will not complain. But this is what you usually do not want because this is a very liberal object and you can have any type of properties inside this object and we want the properties of the object to be strictly typed. So in order to do so, we can add properties to this particular object. So we can copy these properties that we want to add. And here we can say that author is going to be of the type string. Content will be a string as well. And finally, the title of the article is also going to be a string. Now this post object is strictly typed. One thing that you want to notice over here is that instead of a comma, I'm using a semicolon while declaring the strict type or the property of this particular post object. So the properties are separated by semicolons when you are declaring the type and they are actually separated by commas in the object itself. Now this post object contains 3 properties, title, content, and author. And if I try to add another property, TypeScript will complain. It will say that this property is not a part of the declared type. So since image is an extra property, TypeScript will complain here saying that image cannot be added to this particular object because that is not defined in the shape of this object. Objects in TypeScript can also have optional properties. So we can have another property and we can call this image. And this can be of the type string. Now, image can be made as an optional property by using this question mark. Now, since image is an optional property, TypeScript will not complain if image does not exist on the object. You can see I have removed image from the real object and TypeScript does not complain because it knows that image is an optional property and it might or might not exist within an object. Next, let's try to understand the concept of type aliases in TypeScript. Considering this previous strictly type object that we had created, this kind of a syntax is very verbose and is difficult to understand. Right now, our post object has just 4 properties, but eventually these properties grow. And as the properties in the object grow, it becomes very tedious to type your objects like this. To counter this kind of a problem, we have something known as type alias in TypeScript. Type aliases are custom types that you can create and give them a name of your choice. So let's declare a type alias using the type keyword and let's call this type alias as post. This type alias is an alias for this kind of a structure. So we can copy all these properties of our post object and paste it inside our type alias. Now type alias post can be used wherever you want to have an object of this kind. So here, when we declare the post variable, instead of using this literal syntax, we can say that this post variable is going to be of the type post. What you have basically done over here is that created a custom type alias, called it post, and now post should contain all these properties. The advantage of doing this is that types can be declared separately from objects. So this makes your code much more readable. And also post type can be assigned to any other variable apart from post. So for example, you have another variable called blog, which contains all the properties of the post like so. Now this blog can also be assigned the same post type because it has all these properties of the post type. Now, type aliases necessarily don't belong to objects. You can create type aliases for anything else. So we can have a type alias for a string array as well. So like so, we can declare a string array and this can be considered as a type alias. You can name type alias the way you want. There is no hard and fast rule, but the industry norm is to use capitalized camel case. So S needs to be capital here if you want to follow the industry norms. You can use type aliases to declare as many custom types as you want in TypeScript. Type aliases are a widely used feature and they are the basis of creating custom types in TypeScript. Now, since we understand type aliases, we can take a step further to understand union types. Union types are combination of two types in TypeScript. So using the type keyword, let's declare another type. Let's call it DOB, a short form for date of birth. Now, date of birth can be a union of string as well as number types. So you use the pipe operator in order to declare unions. And what this union signifies is that date of birth type can be of the type string as well as of number. Now, there is no restriction on how many types you can add to this union. So apart from string and number, I can also add a Boolean type. Now, considering this DOB type, we can declare variables that are of the type string as well as of the type number. So let's declare a variable. Let's say my DOB. This variable is of type DOB and now it can hold string values as well as number values. Now there can be another variable, so another DOB, and this DOB type can hold numbers, so any epoch value. Now union types are not restricted to combining primitive types. So we have combined strings and numbers over here, but we can also combine different objects. Let's see how that works. Let's say we have a type dog, and this dog type contains three properties: the name of the dog, whether the dog barks or not. So this can be a type of Boolean. And also another property called wags, again a Boolean. So whether he wags his tail or not. And then similarly, we can have another type, this time a cat type. Now the cat will have a name as well. So it will be a type of a string. And then whether the cat purrs or not, and this can be of the type Boolean. Now we can use union types in order to combine these two types. So we can have another type, which is dog and cat type. And this can be a union of dog and cat. Now you will see this dog and cat union can contain the properties of a cat or can contain the properties of a dog or combined properties of dog and cat. And TypeScript will not complain either which ways. So let's declare these objects and see that TypeScript doesn't complain. So first, let's try creating a dog. And this will be of the type dog and cat union. Now to this particular object, I will just assign the properties of the dog. So the name of the dog and whether the dog barks or not. So we'll set this to true. And whether he wags his tail or not, let's set this to false. You will see that I was able to create the dog type and TypeScript is not complaining, and I have assigned a union type instead of a dog type here. Similarly, we can also create a cat and TypeScript will not complain. So again, cat is a type of dog and cat type union. And here the name of the cat, let's call her Bella. And whether the cat purrs or not, let's set this to true. Now you will see the moment I have created these two properties, TypeScript doesn't complain because it understands that dog and cat type union can be of the type cat as well. And that's what I'm doing over here. Now we can also create a hybrid animal, which is neither a cat or a dog, but is a combination of cat and dog types. So we assign a dog and cat type. Let's give it a name as hybrid. Let's set barks to true, purrs to true as well. It's a strange animal, and wags to false. Here you will see that I have created this hybrid animal and TypeScript accepts it because it knows that hybrid animals can contain properties of both dog and cat type. Union types exist in TypeScript quite often and are a pretty useful feature. Now let's look at how functions work in TypeScript. There are three different ways of declaring functions in TypeScript. Let's first declare a function in JavaScript and then try to understand how can you convert that function into a TypeScript function. So here are three different ways of declaring a function in JavaScript. Let's create this intro function. Now this intro function takes in a name as well as an age, And this is a simple function. All it does is it returns a string. My name is string interpolation name and age is string interpolation age. This is a simple way of declaring a function in JavaScript. Let's see another way of declaring the same function in JavaScript and using a constant this time. So intro2. So you declare a constant intro2, and to this constant you assign a function like so. This is a valid way of declaring functions in JavaScript. And finally, you can also use arrow syntax. So const, let's call it intro3, and then you assign an arrow function. This arrow function returns this particular statement, and then it takes these two arguments like so. So these are the three different ways of declaring a function in JavaScript. Now let's convert these to TypeScript functions. So name becomes a type of a string and age becomes a type of a number. So you have specified over here that name parameter is always going to be a type of a string and age is always going to be a type of a number. And since this function in the end returns a string, you can use a colon over here signifying that this function will always return a string. Now this function has been converted into a TypeScript function, and this is how you can read this. The function takes in one parameter, which is string, second parameter, which is age, and returns a string in the end. Now we can do the same thing for intro2 function as well. Here name is a string, age is a number, and this function returns a string in the end. Now let's do the same thing for intro3 function as well. So name is a string, age is a number, and the function returns a string. You will see TypeScript doesn't complain, and all these three syntax of declaring a function are valid syntaxes. With this introduction of TypeScript, you should be able to get started with TypeScript. I would like to point out that I have a detailed advanced course on TypeScript. These are the various sections of the curriculum of that course. So you learn all about types, followed by all about functions, generics in TypeScript, classes and inheritance, and so on. This course is very detailed. You can look at the curriculum of the course and check out all the lessons that are taught within the course. This course has more than 250 videos and 20 hours of content. I teach you everything about TypeScript, including how to use TypeScript in a real world project. And in this course, we build a project using React as the front-end framework, Node as the backend framework, and using React and Node both along with TypeScript. The link that I've shared in this particular video contains a discount coupon as well, so you would get a discount based on your geolocation. Subscribe to the channel if this video has been helpful. Thanks for watching.